Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing how to graph exponential functions. So in the last lecture we talked about the graph of f of x equals 2 to the x. And as it turns out, with a couple of ideas we can basically get every other type of exponential graph of the base form b to the x. So for any base, as long as that base is greater than 1. So as we saw last time, if you plug in 0, b to the 0, again, as long as b is greater than 1, anything not 0 to the 0 power is equal to 1. So input 0, get out 1. As it turns out, that's true for all. And if you plug in 1, you're just going to get back your base. So you plug in 1, b. So 1 and then b, wherever b is. However far b is up on that tree. So 1b. Okay. And then it's going to have a horizontal asymptote of y equals 0. So again, always note your asymptotes. And then we have that it's really small over here, and it grows really quickly here. Something continues to shrink. I'm not doing a good job of notating that, but we get something like this. All right, and from this, we can always get a couple of base points. So this is a base point, and this is a base point. This is true for all of them, and this one it depends on whatever your base is. So we can go back to what we talked about in previous sections about transformations to base graphs. So if we have a base function, b to the x, we can talk about things that are being done. So here, the transformation, we're shifting up 1 because it's a positive, and this negative in front does a vertical or a reflection over the x-axis, or a vertical reflection. And remember, when you're doing transformations, the one you do last is always the shifts. So our base graph is 2 to the x, which we're going to note down here. So we just need 2 points, 0, 1, and our base, our other base point is 1, 2. So 0, 1 is for all of them, and then we have 1, 2. We have the horizontal asymptote. Looks something like this. And then we're going to, again, always do shifts last, so we're going to do the reflection first. So this, the points 0, 1, and 1, 2, since it's reflecting over the x-axis, this one, the y values are going to become negative. So you're going to take the y values and make them negatives of themselves. So instead of 0, 1, and 1, 2, it's going to be 0, negative 1, and 1, negative 2. And we still have the horizontal asymptote. And then lastly, we're going to shift up 1. So again, when you're shifting by adding 1, you're going to take the y values. Again, plus 1 is on the outside of the function, so it affects the y values. You're just adding 1 to those y values. So instead of 0, negative 1, and 1, negative 2, you're going to have 0, 0, because we're adding 1 to negative 1. We're going to have 1, negative 1. So again, these 2 points just get shifted up. And we have, as it turns out, our horizontal asymptote of y equals 0, which is still the case from the original one, again, we add 1 to all values, including the horizontal asymptote. So we now have a horizontal asymptote at y equals 1. And this allows us to create the graph. And this is g of x. And we just need to note two values. All right. Further, we get, if we look at g of x equals 2 times 3 to the x plus 1, here we have two things going on. So here, the outside was plus 1. So the inside must be the exponent. And we have plus 1 on the inside, so that means that we have a shift left of 1. Again, inside goes left or right, outside is up and down. So the plus 1 goes up 1. And again, when it's on the inside, it goes backwards. So instead of going right like you might think, it goes left. And then further, we have multiplied by 2. Again, that's outside the main base function. In this case, 3 to the x is our base function. And we have as well a vertical shift, since it's being multiplied on the outside, by 2. So it affects the y values. So 3 to the x, which gives us a base point of, when we plug in 1 for x, we get out 3. So we have 0, 1. 1, 3. We have a horizontal asymptote. This. And then we're going to vertically stretch by 1, so or by 2. So we take our y values and multiply them by 2. So we get y's go to 2y. So instead of 0, 1, it's going to be 0, 2. And instead of 1, 3, it's going to be 1, 6, which is a little bit above what we have. So we're going to have to just make do. And then we still have the vertical asymptote, or horizontal asymptote, excuse me. Y equals 0. Again, it affects the y's, but if you multiply it by 0, well, it's still 0. This is a really good, important idea of why order matters of when you do these, because if we shifted it up, or if there was a shift up, that would then affect the horizontal asymptote. However, we then have to shift left, and left or right affect the x values. And again, left would be subtracting, so subtract 1, or just move it to the left. So instead of 0, 1, it's going to be negative 1, 1. Or excuse me, 0, 2, it's going to be negative 1, 2. Excuse me. To have the horizontal asymptote at y equals 0. And then we also have, instead of 1, 6, it's going to be 0, 6. Let me just make our graph. And this is what we get. This is our g of x. This is our f of x. I notated it wrong up there. This was supposed to be, oops, double notated it wrong. This is f of x, this is g of x. Excuse me. This is g of x. All right, that concludes this lecture.